Hi everyone, welcome to the session. So welcome to BYJU'S Exam Prep, the most comprehensive exam preparation platform. So today's session is on communication. Yesterday one session happened on communication. So today also another session on communication. So today the topic that I'll be dealing with is digital communication. So we'll be practicing few questions on digital communication. Okay, and I also want to remind you about the session at 9:30. At 9:30 there is a general session. If you have not performed well in GATE, so how should be your thought process? And I'm going to take the examples of some students who are in the same situation as you previously 3-4 years back and succeeded well in their careers. So I'm going to tell you their stories as well, so that it will give you a thought process to develop, and it will give you more motivation as well. So we'll meet at 9:30 for that session. So for now, let me continue with this session. Right. Right. So this is my profile. So I have 10 plus years of experience, and I've done my master's from IIT Madras. I've cracked GATE twice, and I used to work for these institutions earlier and many other institutions as well. So my subjects of expertise is communication systems and signals and systems. So, and this is my Telegram group. So if you wish to ask me any doubts on these two subjects or any general doubts that that you believe that I could help you with, then you can definitely post in this group. Right. So let's continue with the session. Right. So this is the first question based on sampling. So can you try to answer it? Try it out. I have given you two sync functions are involved here, and you have to use some basics here. Using your basics, if you are able to figure out the bandwidth of the signal x of t, then it will be easy to figure out the sampling rate. So they are not talking about sampling rate, but effectively they are talking about sampling rate only. They are talking about maximum time gap between the samples of the signal x of t. They are talking about samples. Samples means they are talking about sampling. Okay, so when they are talking about sampling, they can talk about sampling rate or sampling time. So they are saying time gap, which means they are talking about sampling time. Okay, whenever in any question they are talking about sampling rate is dependent on bandwidth. For any signal, if you know the bandwidth, you can tell the sampling rate or Nyquist rate. So the most important thing to figure out is first the bandwidth. Once you can figure out the bandwidth, sampling rate is easy to find. Right. So Fs is greater than, sampling rate is greater than or equal to 2b. This is what sampling rate is. If you sample at a rate greater than or equal to twice the bandwidth of the signal, then whatever samples you got, if you sample at this rate, then whatever samples you got, from that samples you can reconstruct the signal back. But you don't satisfy this criteria. If you collect samples less than 2b, then from those samples you can't get back the original signal. Okay, right. So what is B? B is the bandwidth of the signal that we are sampling. So here what we are sampling is x of t. So for x of t, whatever is the bandwidth, that we have to figure out. If you figure that out bandwidth, then you can substitute here and you will understand the sampling rate. Right. So to figure that out, first we have to understand the bandwidth of this signal, and bandwidth of the total signal. Okay. Right. So before doing that, let me revise few things. Just recollect a few things. Okay, so sin AT by pi t. I have discussed this in the previous classes also. Sin AT by pi t. This is one form of sinc function. For this function, you know the Fourier transform, which is a rectangle function, which takes values from minus a to plus a as a function of omega with a height of 1. So Fourier transform sinc function is a rectangle function. So what is the bandwidth of this signal? Bandwidth of this signal is, it is a radians per second, because that is the maximum frequency present in that, or we can also write it as a by 2 pi hertz. Similarly, how about this one? This is also another sinc function. It is like sinc of AT, which you can write it as sin pi AT divided by pi AT. See this one, in place of a we are having pi a. In place of a we are having pi a. So what would be the bandwidth of the signal? Whatever is inside sine function, inside the sinc function, whatever is here divided by 2 pi will give you the bandwidth. So this one, this format of sinc function also we have expressed it in this format. In this format we know the Fourier transform, so we can find the bandwidth. So whatever is here is pi a. So if you draw the Fourier transform for this, it will be from minus pi a to plus pi a. So bandwidth will be pi a radians per second, or if you divide it with 2 pi, you will get it as a by 2 hertz. So whenever you see this kind of signals, you can find the bandwidth in the same way that we have analyzed here. So if you can remember these things, that's fine, you can use that, or if you don't remember, that's fine, you can use the Fourier transform concept. You know the Fourier transform sinc function, using that you can get the bandwidth of sinc function in this format or in this format. Right, could you tell me what is the Fourier transform of this, what is the bandwidth of this signal? Sin AT by pi t, this is in the same format. What is a value here? 3000 pi. 3000 pi divided by 2 pi will give you 1500. 1500 is the bandwidth of the inside sinc function. But when you square it, what happens? When you square it, bandwidth will become double. When you cube a signal, bandwidth will become triple. Whatever power you raise a signal to, bandwidth will increase by those many times. So bandwidth of this total signal, inside part bandwidth is 1500. Because of squaring, bandwidth will become 3000. And how about the bandwidth of this one? It is in the same format as this. Bandwidth is a by 2. In place of a we are having 4000, divided by 2 is 2000. Now when two signals are added, what is the bandwidth of resultant signal? When two signals are added, bandwidth of resultant signal is x1 of t, let's say, plus x2 of t. If the bandwidth of the first signal is b1, and if the bandwidth of the second signal is b2, bandwidth of the total signal is maximum of b1 comma b2. You can easily figure out, find the Fourier transform of x1 of t, find the Fourier transform of x2 of t, just add them up. If you add the Fourier transform of both of them, what will be the highest frequency? If x2 of t is having higher frequency than x1 of t, that will decide the bandwidth. If x1 of t was having higher frequency, then x1 of t's bandwidth will decide the final bandwidth. So that's why the bandwidth of these two, the resultant signal is maximum of individual bandwidths. Not only when you add the signals, if you subtract the signals also, it's the same thing. Right, let's use that. So what is the bandwidth of the total signal? When you add or subtract, bandwidth is maximum of individual bandwidths. So the bandwidth of this total signal is maximum of, for this one, bandwidth is maximum of b1 comma b2, which is 3000 comma 2000. And how much is that? Maximum of these two values is 3000 only. And what is the sampling rate? What does sampling theorem say? Fs should be greater than or equal to 2 times b bandwidth, which is 3000. So sampling rate is greater than or equal to 6000. So they are not talking about sampling rate, they are talking about sampling time. So just invert it. Fs can be written as 1 by ts. Ts is less than or equal to 1 by 6000. 6000 means 1000, you can take it to the numerator and you can write it as milli. Since we are talking about time, we can write it as seconds. So it is 1 by 6 milliseconds, which is option A. In BARC can you see no aptitude questions? Teja, I have not seen, I'm not sure actually. I'll update you. As far as I remember, there is no aptitude questions. I'm not sure. I'll update you later, okay? Fine. Okay. Give me a second. Okay, give me a few minutes. I'll just come back. So this board is like slightly different. I'm not able to access this. Just give me 2 minutes. Take it to next slide. I've come to home back. So do something. Okay. Hey, hi. So there was some problem with my smart board. So okay. So we're done with this question, right? So it's 1/6 milliseconds. Just now we solved it. Right. So next question. Again, a question on sampling. So I've given you a sinusoidal signal, and this is a little tricky one. You have to analyze carefully. It's not a very straightforward question. You have to do some amount of analysis. Let's do it. Wait for a few minutes. Anyone can do it and tell me the answer quickly. Simple analysis. In my previous sessions also, I have solved many problems like this. Even I have solved many tough problems than this before GATE exam, whatever sessions I have taken. So since this is BARC exam, I have reduced the difficulty level and I have given similar question. Okay, so people who know how to solve it, you can start solving it. People who are not confident of this kind of questions, just look at the board and just focus on whatever I'm going to teach you. So 8 cos 1600 pi t. Fourier transform. What is the Fourier transform of this one? Impulses at 800 and minus 800, right? Okay. First signals Fourier transform I have plotted. Next, they're talking about sampling. What happens when you sample? Whenever I'll just recollect the concept of sampling. If x of t Fourier transform is x of omega, then if x of t is sampled, we can imagine the sampled signal as x of t multiplied with sigma del of t minus nts. We can mathematically represent a sampled signal in this manner. Okay. Once you represent it that way, the Fourier transform, if you can find the Fourier transform, you can figure out the sampling analysis very easily. Whenever you're talking about sampling, you try to analyze the Fourier transform of sampled signal. So what is the Fourier transform of sampled signal? It becomes x of t Fourier transform becomes x of omega, and multiplication becomes convolution, and sigma del of t minus nts Fourier transform is sigma del of f minus n times 1 by ts, or n times fs you can say. So which can be written as, when you convolve any signal with impulse, it's the same signal shifted to the location of the impulse. You can also write it as sigma x of omega minus n times omega, yes you can write, or you can also write as x of f minus n times fs. That is also fine. So that's more easier way to understand, because it's comfortable. We are more comfortable in dealing with f. X of f minus n times fs, where I did not write the limits, but always the limits are from minus infinity to plus infinity. Okay. So when you sample a signal, what happens? So look at this as x of omega. Then how will the spectrum of the sampled signal looks like? If this signal is sampled, this is like x of t, and x of t into sigma del of t minus nts. This is the sampled signal in time domain. I did not write cos here. If you want, you can write. The Fourier transform will be like this. Let us plot it. Observe carefully. If you know it, you can do it on your own. If you don't know how to do, or if you are having any confusion, just focus. Right, x of f minus nfs, sigma x of f minus nfs. So try to understand the meaning of this. N running from minus infinity to plus infinity. So it is summation of lot of terms. What is the first term? When you put n equal to 0, it is x of f. When you put n equal to 1, it is x of f minus fs. When you put n equal to 2, it is x of f minus 2fs. So there are many terms, infinite terms in fact. So let us plot each and every term. We don't need to plot all the terms. Just for n equal to 0, 1, 2, if you can plot, that is sufficient. So let us plot x of f. X of f, we already know the spectrum. Let us just copy it. 800. Okay. Next. So area of these impulses is also important, because the amplitude of cos is 8. The area of these impulses will be 4 units each. Okay. So one more point I have to write here. So Fourier transform sigma del of t minus nts is, yes, this is correct, but there is a one extra factor. It is 1 by ts is the extra factor. 1 by ts is the extra factor. 1 by ts means it's nothing but fs. Okay, that 1 by ts factor is also there. You have to be careful here, because the question asked involves these amplitudes also. Amplitudes are also very important. Since if they are testing us only on frequency part, then if you don't worry about the amplitudes, that's fine. But in this problem, because cos signal is given and its amplitude is given, you have to make sure that you are doing amplitudes correctly. Okay. So right, what did I plot till now? X of f I have copied just as it is. So what is the height here? It is 4. It is 4, but 1 by ts is also multiplied, not just x of f here. X of f is multiplied with 1 by ts. And what is 1 by ts? 1 by ts is fs. And what is fs? Fs is given as 1000 samples per second. So 1000 also should be multiplied here. So it is 4000 is the area of this impulse. 4000 is the area of this impulse also. Okay. Next, let us plot x of f minus 1 times fs. I am talking about n equal to 1. So fs is 1000. So we are going to plot x of f minus fs, which is x of f minus 1000. Let us plot x of f minus 1000. X of f minus 1000 less x of f shifted towards the right side by 1000. When you shift these two impulses towards the right side by 1000, minus 800. Impulse at minus 800 will go to 200. And impulse at 800 will go to 1800. Similarly, we put n equal to minus 1. It will become x of f plus fs, or x of f plus 1000. Then these two impulses will be shifted towards left side. Impulse at 800 will come to minus 200, and impulse at minus 800 will go to minus 800. Like that, you can plot other variants also. I have plotted only x of f minus fs, and x of f plus fs. You can plot x of f plus fs, f plus 2fs, f plus 3fs, x of f minus 2fs, f minus 3fs, and so on. But all those terms are not required. Why it is not required, you will understand. So this sample signal, what we are doing, we are passing it through low pass filter of bandwidth 550 kHz. We are passing through low pass filter of bandwidth 550 kHz. What does the low pass filter do? It allows only frequencies from minus 550 kHz to plus 550 kHz. So let me draw a rectangle here to indicate minus 550 kHz and plus 550 kHz. So the height of these two impulses is all same, which is 4000. Correct? Same height, na? X of f, if you shift it, the height will not change, and you are multiplying with 1 by ts. The height of these two impulses, all the impulses is same, which is 4000. And we are passing all these impulses through a filter whose cutoff frequency is 550 kHz. And here it is minus 550. Now, if you pass all these impulses through this low pass filter, this is low pass filter what happens? What is the output of low pass filter? The output of low pass filter will be, low pass filter allows only these two impulses. The impulse is at 200 and minus 200, that's it. And with a height of 4000 on both of them. Or it's not height actually, it's area of the impulse, because the height of the impulse is infinity. Right, so we got it. We got the Fourier transform of the signal at the output of low pass filter. What is this? This is output of low pass filter. Yes, we almost got the answer, but find the output of low pass filter, but they have given the signal which is in time domain. We got the answer, but this is in frequency domain. Let us convert this into time domain. This is in frequency domain, which means Fourier transform we have. Let us get the inverse Fourier transform. So can you tell me the inverse Fourier transform of this one? See this one, whatever is the amplitude of cos, that amplitude is half of the value is available here. So whatever is the area of the impulse, that is half of the amplitude of sinusoidal signal. So if it is 4000 and 4000 here it should be 8000. And two impulses means it always represents a sinusoidal signal. So it is cos of, it is 2 pi times the frequency into t. Whatever is the frequency available here, that is the location of the impulse. The location of the impulse is 200. In terms of angular frequency, it is 400 pi. So it is 400 pi t. So the inverse Fourier transform of this one, you find it in any procedure that you know, you'll be getting it like this. So that is the answer. This is the output of low pass filter. So the answer is 8000 times cos 400 pi t. I think two options are same. Oh, I think they should have given some other option. Okay. Some typo mistake. And that's why two options are same. Fine. Okay, wonderful. Any confusion here? I've gone a little quickly here because this is an entirely different concept on sampling. I've just recollected what should be recollected here. I did not go into the depth of explaining you sampling. Okay, I've just revised that part and I've used it in the problem. Okay. Fine. Shall I move ahead, or if there is any doubts, you can ask me quickly. So I'm assuming it is clear. So I'm moving ahead to the next question. Let us solve this one. This is also a good question. If you know Fourier transforms, the concept of Fourier transforms, the concept of modulation well, this also can be solved under 2 minutes. Can anyone solve it and tell me the answer? I'll wait for a minute and then I'll start doing it. Do it carefully. There is nothing to get confused. Fourier transform of the signal is given. DS-based signal using a message signal with Fourier transform as shown in the figure. You can take the message signal Fourier transform as x of f or m of f, anything is fine. Any notation is okay. A carrier signal of frequency 100 kHz is DS-BSC modulated. So what did they tell us about carrier signal? It is AC cos omega CT, or you can also write as AC cos 2 pi FCT. FC is given as 100 kHz. 100 kilo means 10 power 5. Okay, that is the carrier signal. And message signal equation they did not give in time domain. So let us take the message signal as m of t. And what are they saying? They're talking about DS-BSC signal. S of t is the notation for modulated signal. So in that modulation also, specifically the modulation is DS-BSC modulation. So what is the equation of DS-BSC modulated signal? It is m of t message signal multiplied with carrier signal. So this is the equation of DS-BSC modulated signal. So message signal m of t, and we know the carrier, it is AC cos 2 pi 10 to the power of 5 into t. Right. So when they're talking about minimum sampling rate required to sample the DS-BSC modulated signal. So whenever they are talking about sampling rate, you have to figure out the bandwidth, or you have to figure out the Fourier transform of the whatever signal you are sampling. First you should know the Fourier transform of that signal. They are sampling the DS-BSC modulated signal. Let us find the Fourier transform of DSBSC modulated signal. So what is the Fourier transform of DSBSC modulated signal? It is, so Fourier transform of m of t into cos, it is AC by 2 into m of f minus fc plus m of f plus fc. Or when you multiply a signal in time domain with sinusoidal signal, what happens in frequency domain? Shifting happens. Signal m of t is multiplied with sinusoidal signal with a frequency of 10 power 5. So if you see the frequency domain spectrum of this signal or Fourier transform of this signal, the spectrum of m of t, this spectrum will get shifted towards right side by 10 power 5 and left side also by 10 power 5. Okay, right. So let us plot the spectrum. Let us plot m of f minus fc, m of f we have. Let us shift this by fc towards right side. What is fc? fc is 10 power 5. So let us shift this towards right side by 10 power 5 or 100 kilohertz. If you shift this towards right side by 100 kilohertz, minus 100 kilohertz will go to 0 and plus 100 kilohertz will go to 200 kilohertz. Next, m of f plus fc, same signal, shift towards left side by 100 kilohertz. You will be having this kind of signal. Okay, right. So now you got the signal. So this is the Fourier transform of DSBSC modulated signal. So is this a band pass signal? Actually, it was supposed to be band pass signal. DSBSC modulated signals are generally band pass signals, but is this a band pass signal or is this a baseband signal? There is no gap here. So it's a baseband signal only. For a baseband signal, how do you find the sampling rate? Sampling rate, you can find it as sampling rate. It should be greater than or equal to 2 times bandwidth of the signal, or bandwidth means highest frequency. So it should be fs greater than or equal to 2 times 200 kilohertz is 400 kilohertz. So minimum sampling rate required is 400 kilohertz. Okay. If it was band pass signal, and if they have asked the same question, let's say if there was more gap here, so let's say if the highest frequency, whatever is the highest frequency, if the gap between the zero frequency and the starting frequency of this signal, if the gap is more, then you are going to treat it like band pass signal and you have to apply the formula of band pass sampling. I hope you remember the concept of band pass sampling. So you have to apply the formula of band pass sampling that is completely different from this. Okay, very good. That was 400 kilohertz. Very nice. Right, I am moving on to the next question. Try this one. I mix the concept of sampling, PCM, and one more small funda. Look at it, understand it carefully, and do it. It's Pcm signal. A signal as shown in the figure is to be sampled, quantized and encoded using 8-bit Pcm system. Pcm system, what does it do? It converts a signal, an analog signal, into bits, right? When it is converting into bits, number of bits used per sample to encode, that is important. Sampling rate is also important. But they did not give us what sampling rate is being used. Whenever there is no information about sampling rate, what should you do? What sampling rate can we assume? Whenever there is no information about sampling rate, just assume that they are using Nyquist rate or the minimum sampling rate they are using whenever there is no information. Okay, very good. So sampling rate, they did not give any information, you can take it as 2b. Okay, and message bandwidth is clearly 400 kilohertz, so it is 800 kilohertz, that is the sampling rate, right? Now, so they are using PCM system. For a PCM system, you are going to sample first, quantize and then encode. So after encoding, the number of bits that we will have, or the bit rate, will be n times fs. That is the bit rate, simple formula, number of bits per sample into samples per second. So which is equal to, bit rate is equal to, n is 8, it's because it's an 8-bit PCM system, 8 bits are used per every sample you are converting into bits using 8 bits. And the sampling rate is 800 kilo, which is 8 8 is 6400 kilo bits per second, because we are talking about bit rate, it's bits per second. So we got the bit rate. What is the meaning of this? Meaning of this is, bit rate means how many bits we are transmitting per every second. So 64,000 bits we are getting every 1 second. And what are they saying? If the samples are collected for 10 seconds, if the samples are collected for 10 seconds means you're trying to store the bits that are collected within 10 seconds. So how many bits will be there in 10 seconds? If in 1 second, if there are 6400, in 10 seconds there will be 64,000 bits. How many bits are collected for 10 seconds? 64,000 bits. You want to store them. So the answer is 64,000 bits, but they are asking is in bytes. So how many bytes is equal to 1 bit? 8 bits is equal to 1 byte, right? So divide with 8 to convert it into bytes, which is 8,000 bytes. 1 second, kilo, right? I think I missed kilo part. Kilobits, kilobytes, or 8 megabytes. 8 mega, that is the answer. Very good, you have done it very quickly, very nice. So shall I move on to the next question? Okay. Next question is based on quantizer. If your basics are clear, this should not be a difficult question. Read the question carefully, understand it properly, understand what they have given, and understand what they are expecting us to find. Once you understand those two things correctly, what they have given and what they are asking us to find, half of the question is done. So this is the quantizer characteristics, input versus output of quantizer characteristics. So find the value of A. They are asking us to find the value of A so that all quantization levels are equally probable. First figure out what are the quantization levels available. What are the quantization levels? At the output of quantizer, what voltages will be there? This is the input to the quantizer, this is the output of the quantizer. What are the values Y takes? Y takes a 0 value and a 2 value and minus 2 value. Only these are the 3 values that the output of quantizer takes, or Y takes. So Y takes only 3 values, which is minus 2, 0 and plus 2. These are the only 3 values output of quantizer will take. So we can call them as quantization levels. So we want them to be equally probable. So we want P of Y equal to minus 2 to be same as P of Y equal to 0, which is also same as P of Y equal to 2. Okay. So what is P of Y equal to minus 2? When do you get P of Y equal to minus 2? We get P of Y equal to minus 2 when x takes these values. When x takes values from minus 3 to minus a, that is when you get y value as minus 2. Y takes minus 2 value when x takes values from minus 3 to minus a. So the probability with which y takes a value of minus 2 is same as the probability with which x takes values from minus 3 to minus a. And what is the probability with which y takes a value 0? Y takes a value 0 when x takes a value from minus a to plus a. The probability with which x takes values from minus a to plus a is same as probability with which y takes a value 0. And similarly, you can write for y equal to 2 also. Right. Now let's figure out this one. What is the probability that x takes values, because P of x is given here. What is the probability that x takes values from minus a to plus a? It is just this area, right? This is just the area that they're talking about. They're talking about the area from minus 3 to minus a. Minus 3 to minus, they're talking about this area. What is this area? Height I did not give, but we can find, because this is PDF, area should be 1. So width is 6 units, so the height should be 1 by 6 units. So what is the area of this part? It is, height is 1 by 6 into what is the width? Minus A minus of minus C is 3 minus A. This width is 3 minus A, which is equal to, what is the probability that x takes values from minus A to plus A? Talking about this area, sorry, this area. So width is 2A and height is 1 by 6. 1 by 6, 1 by 6 cancel. So 3 minus A is 2A, which is 3 equal to 3A, which means A should be equal to 1. Voice is breaking now also. Okay, there was some, I think there was some internet issue, I think. So that's why there is a small lag also in the video. So kindly adjust regarding that. I can't do anything about it. Is the voice okay now? So answer is A equal to 1. I think some of you have done it already. Very simple process. Can you update me about the voice part? Okay. Try this one. Try this one. This is based on delta modulation. I have given you sampling rate. You know the concept of slope overload distortion. Right. So first thing is you should plot that signal first. You should imagine the graph of it. If you can plot the graph of that signal quickly, then it will be easy to figure out the question. So R of t. If you R of t just looks like this, because minus 2 R of t minus 3 is there. At 3 units the shape will change. It starts sloping downwards because this is of slope 1 unit and this is of slope minus 2 units. So starting from 3, the effective slope will be 1 plus minus 2 is minus 1. So it will be going downwards with a slope of minus 1. And then at 6 units, the slope of this is 1, slope of this is 1, slope of this is minus 2, effective slope will be 0. Slope is 0 means it will become constant after that. So this is how the signal looks like as a function of time. And what is the height here? Since the slope of the signal is 1, so till 3 only that signal exists. So since slope is 1, in 3 units of time the height will increase by 3 units. So this is how the signal m of t looks like. And what is the slope here? 1 unit. And what is the slope here? Minus 1 unit. Right. They have given the sampling rate as 100 samples per second. And they are saying they are digitizing using delta modulator. So they are asking us about slope overload distortion. So because this is having constant slope signals, whenever there is constant slope, it is possible to avoid all types of distortion, not only slope overload distortion, but all types of distortions. So the funda for no distortion is d by dt of m of t, magnitude of slope of the message, if it is matching with the speed at which the staircase of the step delta modulator increases. The speed at which staircase of delta modulator increases or decreases, that is delta by ts. If these two match, the value of step size for which this matches, that we call it as optimum step size. So in these kind of signals, not only slope overload distortion, all the other distortion like granular distortion also can be avoided. But for the other signals like sinusoidal signals, where the slope is not constant, for those signals we can avoid only one distortion, that is slope overload distortion. Right. So what is the slope of the signal? Maximum magnitude of slope is 1 unit. But generally what they are talking about is, since they are talking about slope overload distortion, whenever they say slope overload distortion, anyway in this case answer will not change whether I take the general no distortion case. This is no distortion case always. I'll write it. No distortion at all. If a signal satisfies this condition, or if you choose a step size so that it satisfies this condition, no distortion at all when you are doing delta modulation. But if you don't want no slope overload distortion, for some kind of signals you can't avoid all types of distortions, right? So then what kind of questions will be asked is, for non-constant slope signals, for signals without constant slope, for varying slopes like sinusoidal signals or other signals, they can only ask you about no slope overload distortion. They will not ask you about no distortion. So what is the condition for no slope overload distortion? The condition for no slope overload distortion is, slope overload distortion happens when message slope is dominating. When message slope is dominating. So you don't want the message slope to dominate. So you have to increase the step size. So delta optimum divided by Ts, you choose the step size in such a manner that message slope never dominates. If the message slope is not dominating, magnitude of message slope or the slope overload distortion happens when message slope is more. So what we are interested in, not just the magnitude of slope, because slope is changing, right? If I am writing only modulus of d by dt, it is a changing value. But I can't do any calculation with changing value, right? So I have to take the maximum value, because to avoid slope overload distortion, we should design the system according to maximum slope. We should design the system according to maximum slope. Right? This is the condition. Whenever they say no slope overload distortion, you should use this condition. Whenever they say no distortion, which happens only for constant slope signals like this, see here, magnitude of slope is constant, magnitude of slope is constant. Sir, slopes are not constant, not constant. Magnitude of slope should be constant. Right. So for this kind of case, you can use any formula, you will get the same answer. Okay. So step size is what they are asking. So 1 by Ts, I can write it as Fs greater than or equal to. What is the maximum slope of the signal? It is 1 unit. So delta optimum should be greater than or equal to 1 by Fs. What is Fs? It is 100 samples. So which is equal to 0.1, 0.01 volts, correct? Yes, very good. It is 10 millivolts, you can say. Is that okay? Mrunal, you are saying 10. I think it is, I did not give you any millivolts, right? The answer should be in millivolts, right? So I think, yeah, 10 millivolts is fine, or 0.01 volts. Okay. So I've revised a few things about slope overload distortion also. You can use that whenever that kind of question is asked. Yes, in this question I'm testing you on slope overload distortion. Try this one. Come on. It's a standard question, question on sinusoidal signals and delta modulator, and the question is about slope overload distortion. Message signal slope should not dominate. That is the criteria for avoiding slope overload distortion. So delta by Ts, this is the slope of the staircase signal, that should dominate compared to maximum magnitude of slope of the message. Maximum magnitude of slope of the message. This is the condition for slope overload distortion. Delta we don't know, that is what we have to find out. And what is the sampling rate? That is not given, we have to find that out. So they are saying sampling rate is sampled at 100% higher than Nyquist rate. 100% higher than Nyquist rate means it's like 2 times of Nyquist rate. 100% more means it's like double. 100% higher than Nyquist rate. 100% higher means it's like 200% of Nyquist rate. 200% of Nyquist rate, which is 200% into normal scale. Whenever percentage you want to convert into normal scale, just divide it with 100. You can directly guess what is happening here. Just for sake of some people who are finding difficulty, I am just converting. So you can directly say that it is 2 times of Nyquist rate. Instead of saying double the Nyquist rate, they are giving the sentence in a different way. Right. So what is Nyquist rate? Nyquist rate is 2 times the bandwidth. What is bandwidth? The highest frequency in the signal. In the signal, what is the highest frequency? It is 2000. That is the only frequency present. This 2 2s are 4 into 2000, which is equal to 8000. Since it is sampling rate, it is samples per second we can write, or kilohertz also we can write. Okay. Sampling rate, if they are saying sampling rate, it should be written as samples per second, but sampling frequency, if they say, we can write it as hertz. 8 kilohertz. So we got the sampling rate, right? So it is delta by Ts can be written as delta into Fs is greater than or equal to. What is the differentiation of this signal? It is 20 into differentiation of sine is cos, and it is that 4000 comes outside into cos of 4000 pi t modulus. So delta is greater than or equal to that Fs. So what is it we are interested in? We are interested in the maximum value of this. We are interested in the maximum value of this. What is the maximum value of this one? 20 into 4000, right? So it is 20 into 4000. That is the maximum value possible in this part. In this, that is the maximum slope of the message possible is 20 into 4000 divided by Fs. What is Fs? We just now found it. It is 8000, right? 8 kilo or 8000. So you can cancel the things. So 4 2s are 8. Delta is greater than or equal to 10 volts. So they are talking about optimum value of step size. Optimum means the best value of step size. You can choose any step size which is greater than 10 to avoid slope overload distortion. But what is the best value? If you use bigger step size than required, then what happens? There will be more granular distortion. So the best value of step size that you can use to avoid slope overload distortion is the minimum value possible, which is 10 volts. Yeah, I missed out. Aditya, that is true, man. I missed it. Yeah, 400 pi will come out. Thanks for correcting. Then the answer will change. 4000 pi. 4000 pi. So it should be 10 pi. 10 pi means it is 31.4 volts, right? Yes, Aditya, correct. That is correct. Thank you for correcting. Is that okay? Any doubts? Any questions you want to ask me here? Any doubts? If there is anything that is not clear, you can let me know so that I can explain once again. So I'm moving ahead. Very good. Many people have answered much before. Very good. I did not see that. Okay, this should be an easy question. Who will answer me this? So PDF of a random variable is given, and I'm asking you the height of that shape. This is one property based on which many times questions were asked. The property is area of the PDF is always equal to 1. Area of the PDF is always equal to 1. Integration from minus infinity to plus infinity. If you find the area of the PDF, it should be equal to 1 because total probability will be equal to 1. This is the very simple property and widely used property, you can say. Many times in many questions this property will be used. Okay, fine. What is the area of this one? You don't need to do integration because this is an easy shape. You can find the area directly. So area of this triangle part is half into base into height. Half into base is 4 units into height is a units. Plus what is the area of the rectangle part? It is 6 into a, 6a. This total area should be equal to 1, right? So this is 2a plus 6a will be 8a, which is equal to 1. And a should be equal to 1 by 8 or 0.125. Hi Artha, anyone student? That should be easy question, right? Very good. So moving on to the next question. Similar question, same PDF I've given you. The question I'm asking you is slightly different. In the previous question, we have already calculated that height. You can use that height. What is the height? If it is 8, you can write it here. B is 1 by 8. Now I'm asking to find P of x less than 0. What is the meaning of this? The meaning of this is you are interested in the values of x less than 0, which means you are interested in the negative values of x. And what are you exactly interested in? The probability of those values. How do you find the probabilities of all those values? Take the PDF of x, which has probability information, and try to add up all the probabilities from minus infinity to 0, because we are interested in the values of x from minus infinity to 0. Whatever values of x we are interested, add up all those probabilities. Because it's continuous and variable, since we can't, we want to add up, but summation cannot be used, we have to only use integration. Which is equal to, what is the area from minus infinity to 0? This total area. It is half into, base is 4 units and height is b units, which is 1 by 8. How much is that? 1 by 4 units, right? One by 6 or 1 by 4? Okay. Adarsh, you are asking something? Let me see. Five, 10 minutes. Right. Artha, kindly adjust for today. There is some maybe some internet issue, maybe that's why. Generally, we will not have these issues. I'm in the studio only, not even at my home. Adarsh, you're asking about engineering mathematics, right? Yeah, kindly, can you others suggest, Mrunal, can you suggest him a book about mathematics? Is H.K. Das fine, or do you suggest some other books? Because it's been a long time since I've studied mathematics. Only in engineering and for GATE only I've studied. After that I did not study, so I'm not aware of the books for that. Okay, sure. H.K. Das is a good book, it seems. Adarsh, any other suggestions you want to make to him? Fine. Hi Sishir, very good. Okay. What other book you'll suggest, Mrunal? Ramakrishna, very good. Shall I move on to the next question? Gravel. Okay, yeah, Gravel is a standard book. Even I have, I remember it. Okay, so I'm moving on to the next question. So P of x greater than or equal to 1, I'm asking you, but I have, one second. Is this a PDF? This is not a PDF, no, because the area of this will be infinity. So I did not give you PDF, I have given you CDF. Generally the notation for CDF is we use capital letter. That's fine. What is the notation? That is not important. Based on the shape, we can identify whether it is PDF or CDF, even if they did not mention in the question also. I have mentioned actually, the PDF of a random variable is shown in the figure. When I say PDF of a random variable is shown in the figure, even if they used a different notation also, that should be fine for you. You should not get confused with the notation part. Okay. Right. So CDF is given. You want to find out P of x greater than 1. You want to find out the probabilities of all the values of x greater than minus 1, which means, can we write it as P of 1 minus P of, which means this also means that we are not interested in the values less than minus 1. So I'm removing the probability of the values of x less than minus 1. We are interested in the values of x greater than minus 1. So from the total probability, I am removing the probability of the values of x that we are not interested. So if you observe, we can also write this as, this is looking like the CDF value at minus 1. CDF function value at minus 1. Why did I convert like this? If PDF was given, I could have found the area from -1 to infinity. But since CDF was given, I am trying to convert into CDF form like this. So which is 1 minus, what is the value of this function at -1? At -1, what is its value? The height. We know in a CDF, I did not give you this height, but in a CDF, it will be constant after some time, after some values of x, and the height will be equal to 1. That is the standard property of CDF. Right. If this is 1, then at the midpoint, what will be the height? If the height here is 1, the height here will be half of it, which is half units. It is 1 minus half, which is equal to half. Is that okay? Or what else you can do is, if you are comfortable with only with PDF, differentiate this. You can differentiate this. If you differentiate, it will be constant. From -2 to +2, it is constant. The height is half units, because the slope of this is half units. So that's it. The constant differentiation is 0. This is how the PDF looks like. So if you know how to deal only with PDF, yes, you can differentiate the CDF, you can get the PDF and then do the problem. Okay, fine, very good. I'm moving on to the next question. One more question based on normal distribution. So first I'll revise one thing here. F of x, which is CDF of a normal distribution, is equal to whatever distribution you have, take that, whatever CDF of whatever random variable they have given us, that random variable's CDF. If you have, you can convert this into CDF of normalized Gaussian distribution in this manner: x minus x bar divided by sigma. This is the relation between, when I give subscript as x, I am talking about a random variable x or random variable y. Okay, if this is y, I am talking about random variable y. What is this one? This is the CDF of a normal distribution or Gaussian distribution with mean 0 and variance 1. Okay, and one more thing also I'll revise, the relation between q of x and f of x. Q of x plus f of x is equal to 1, and q of x and f of minus x, these two are same, right? Right, let us do this one. So p of y greater than 8. So since they are talking about y random variable, you can imagine it as y, f of y, fy of y minus y bar by sigma, something like that. So y greater than 8 can be written as 1 minus p of y less than or equal to 8. Why did I write like this? Because I wanted it in CDF form. So which can be written as, this is looking like CDF of y, CDF of y right? One second. Yeah, my mistake. I think I've written it the reverse way. Fx of x. Yeah. CDF of a random variable x at a particular value can be represented in terms of CDF of normalized Gaussian distribution. I've just reversed the relation. This is the relation. So you want to find this, you can write it as f of 8 minus y bar divided by sigma. Let me apply the formula. It is f of y value is given as 8 here, minus y bar. What is the mean value? Mean value is given as 4 units, divided by, what is the variance is 16, but we don't want variance here in the denominator. It is standard deviation, which is the root of variance, which is 4 units. Sigma square is 16, sigma is 4, which is equal to 1 minus f of 8 minus 4 is 4, 4 by 4 is 1. 1 minus f of 1. You can stop it there, or you can also write it as q of x plus f of x is 1, no? So 1 minus f of x, 1 minus f of x is q of x. So 1 minus f of x is q of x, which is q of 1. Or q of 1 can also be written as f of minus 1. In the options you might find any of those three, 1 minus f of 1, q of 1, 1 f of minus 1. Okay. So sure, how can you increase? See, definitely from last year, if you have performed so well, definitely you'll perform this year much better, definitely, for sure, because you might have done some more preparation. So definitely, obviously your chances has increased, definitely. You don't need to do much, just revise whatever you have studied till now. Okay, just revise the notes, revise only the subject part. Problems will be easy only. There will be mostly easy level of difficulty kind of questions will be asked. So don't think too much, you'll definitely clear it this time. Okay. Right, next one. X takes values from 0 to 20, it seems. Okay. Now they talk about y equal to 2x. If x takes values from 0 to 20, what does y do? Y takes values from, starting value of x is 0, so 2x starting value is 0 only, and 2x ending value is 20 to the 40, so y takes values from 0 to 40, okay. And they are saying that x takes values from 0 to 20 with equal probability, which means the PDF of x is given. They are indirectly saying that the PDF is uniformly distributed. So 0 to 20 equal probability means the height will be 1 by 20, so that the area will be 1. Now they are talking about y. So whenever there is a linear relationship between the random variables like y equal to ax plus b kind of relation, the shape of the PDF will be same, or the name of the shape will be same. Whenever there is y equal to ax plus b kind of relation, remember this is a very, very important point. If x, whatever is the name of the shape, whatever is the shape of x, the same will be the shape of the y. That does not mean that the shape will be exactly same. The name of the shape of the PDF will be same. If x is uniform, y also will be uniform, but the width of the uniform PDF might be different. The mean value might be different. If x is Gaussian, y also will be Gaussian. The shape will be same. Name of the shape will be same, not the shape. Name of the shape will be same, right? Since x is here, in this case, it is uniform, y also will be uniform. Okay. So how about y PDF? We know that y also will be uniform, but it will not have the exact same width and all that. That will not happen because y takes values from 0 to 40. How will it have exact same shape? But name of the shape is same. We know that it is uniform, and we know that it takes from values from 0 to 40. Now I think you can figure out now. It is also having uniform PDF and it takes values from 0 to 40. So plot a shape, a rectangle shape from 0 to 40. And what will be the height? It will be 1 by 40. That's it. We got the PDF of y. This is f y of y. Now they are asking us to find p of y less than 10. Y less than 10 means the area from 0 to 10. This area they are asking us to find, which is 1 by 40 into 10. 1 by 40 into 10, which is equal to 1 by 4. Very good, 0.25. Okay, very nice. So that's it guys from my side. So we'll meet again at 9:30. An interesting session is coming up. Don't miss that session. It's a very, very important session. I'm gonna add a lot of value to the way you think. It will be a wonderful session, I promise. Last 2 days I've been thinking about the same session, what to convey to you guys, and I've been talking to a few of my students, and I'll definitely, it will be a very, very helpful session for you guys. I promise that much. And if any students, if any of your friends have also attempted GATE and they are feeling low, little low, they have not performed up to the level they expected, you can ask them also to attend the session. It will be helping them. Okay, right guys, then that's it from my side. Thank you, have a good day, take care, and we'll meet you at 9:30.